it sense out of it. So definitely we need to practice day by day to achieve the same. So thanks for putting that together, and team, definitely you need to leverage the ones that the team is actually putting for you. So there are a lot of effort went in there, so make use of that efforts. And yes, so now and also one more thing that I like from your last slide is Minion, because my son name is Inian, and some of my friends used to call him as Minion, his nickname. So
Great, great.
I
Yeah.
really like that. Okay, thank you, Tibak. And team, if you have any questions around
Thank you.
Terraform Office and anything for Tibak, do not one of your YouTube live chats and post your questions there, and you will get them answered soon. And with that, let's go to the next one. So we have Devesh, and so before we start off with that, I would like to give something around that. So in long back, so maybe around 10 years back, so we don't have easy way of doing things. For example, if you want to make one application setup ready, you have to spend 10 days on it, and you have to make same things again and again for 10 different environments. But one of the simple invention that HashiCorp brought in, I would say it is super simple and easy. I really love that product. So they have made our life a lot easier. So now we have our next presenter is going to talk about that, and how confident you can easily go with this product as well. So yes, so with that I'll leave that to Devesh to take over.
Uh, Hi team, Devesh here.
Okay.
I guess you all can see my screen.
Yes, you can put it in full mode. Yeah.
Hello team. So my presentation is baking machine image with confidence. So just as he mentioned that making machine images is totally a different ball of game in terms of deployment and development of any application, because it takes a lot of time and development, and it's pain in the ass of how we can configure our environment. So we'll start our talk with that. So just a basic introduction on myself. So I'm Devesh Bajaj. I work as a data engineer at Episource. My major responsibility lies around building infrastructure and architecture around events and cloud. So I deal with events, whether it's AWS events, Kafka events, or any webhook events that is traveling in our infrastructure. So we deal with that, we process it out, and we make sure all the infrastructure associated with that event are deployed, managed, and destroyed as per our requirement. And that's all from my end. Feel free to reach me at LinkedIn. There are a few subjects of interest. If anyone wants to talk about it, is animes, MCU, fan theory, space time, and computer coding. So moving ahead. So our talk is majorly revolved around few topics. One is problem statement. What are the problems of machining, building machine images? Why we need machine images? Like in terms of AWS, there is AMI, Amazon machine images. There's on-prem Ubuntu images and plenty of tools. And what are the tools and services that are required to build images with confidence? And one more thing, which is what are the best practices to build images in terms of CI/CD or in our development pipeline, or what we have to use for making our production environment and our testing environment close to similar, because there's one major problem that we face in our non-dockerized environment, which is our production environment is totally different from our dev environment. So first we'll start about problems. So there are two things in our industry or infrastructure. One is called application which can be dockerized, and application which cannot be dockerized. So first I'll talk about dockerized container, dockerized application. The dockerized application are single responsibility application that are packed and they are intended to do only one thing. Uh, so the deployment of dockerized application is pretty simple. You pack everything into your Docker application, you ship it, and you'll run. It will run same as your machine, as on anyone else's machine, whether it doesn't matter with the deployment machine is ARM architecture or any architecture. Just to make sure your Dockerized application is perfect. But there are problems with non-Dockerized application. Why? Because take an example. Uh, for a non-Dockerized application, you have to make sure your environment is configured properly. That means all the helper libraries, all the dev CC packages, GCC packages, and all whatnot system libraries are installed perfectly into your system, and they need to stay perfect because there are a lot of time when a third party package gets updated, and on runtime what we have is we install a latest package, and that leads to the breakage of our entire application. One thing is prod versus dev. That's the long battle that we faced a long time, which is our production environment is totally different from our dev environment. So for dev, we use small instances on laptops, which is not exactly configured as production environment. And production environment is totally lightweight in terms of what all things are present. So for example, in your local machine, there can be a lot of components present. But in production environment, there is only one specific component, which is crucial for the requirement of that application. Third point is dependencies. So this is one of the major thing that at episodes we faced a lot. So for example, take a machine learning model which requires 10 different packages, and you have installed all those packages right now and your application is working fine, and let's suppose you install it again. So if your dependencies are not fixed, or in terms of that, those are loosely bound. So what will happen? The Python package or any package, if the version is not specified, it will try to download the latest one. So you have to make sure your application is compatible with the latest version, otherwise it will break. So at episodes, we have faced this problem a lot in terms of if our any one of the package of the entire requirement or txt gets a little bit gets a bump up, so it leads to the breakage of the entire application, which is not very good at all in the production. So that is the thing that we need to look for in non-Dockerized application. Another is sysadmin. So these are something like there was a time when the Docker was not that popular. So we need an army of system admins whose entire job was to make sure the infrastructure is like the packages installed into that EC2 machines, or anything like for EC2 machines, RDS instances, anything that all the dependencies packages are properly configured to that point. Otherwise, if a single dependency is here and there, it will lead to the breakage of system. So these are the four major problems that we can face with the non-Dockerized event. So another problem. So as I mentioned at episodes, we work with events and a lot of events. So now the problem is tenfold now. So we had a problem with non-Dockerized application, and now we have problems with non-Dockerized application with events. So just take an example. So let's suppose your Kafka cluster is producing a lot of events, and we have a lot of events coming in. And depending on the number of events, we need to launch instances. Or so as you already mentioned that the application is non-Dockerized, so we cannot launch with the help of Kubernetes, Docker Compose, or Docker Swarm, anything. So we have to use our old way of launching an EC2 instance, make sure that configurations are installed properly. So just take a rudimentary example of over here. So there, let's say there are 4K, 40K events are coming in, and based on the number of that events, we launch around 30 instances. So the point over here is we can use Terraform to launch 30 instances as an instance, but the problem comes how to configure those instances. So we can write a lot of bootstrap scripts that will install the necessary package like dev GCC or anything and everything and onto the runtime. But there's a core problem with that is if a single package while we are installing gets break, or there's a network issue at the app, or there is a network issue at any point, any single point, that instance will fail and that instance will become daemon. And so we have to write an entire fallback logic how the things will span out, like what are the ways to make sure that instances fail and it's terminated, and a secondary instance gets launched and whatnot. And after, let's suppose by the God's grace, the application is configured properly. And second, there's an app. So your app is running, that is working fine, it done all its work. Now second terms come cleanup. So we have to delete all our instances that we have deployed. So this is a core problem for event-based non-Dockerized application. The main core problem that comes is configuration. So there can be a saying that we can use Ansible, SaltStack. There are plenty of tools in the market that can help us with configuration. So the example that I mentioned, that app can fail. So you can ask me that we can have retries and all. But the problem over here is every time the instance is launched, it is configured. And there's a probability that either instance get the configuration get failed, or there is a package dependency or a version bump of a third party tool will lead to the failure. So that's the thing that is crucial. Another point coming on to that, machine images. So there's just simple definition of machine images for everyone to have a basic understanding. So machine images is nothing but an exact replica of the EC2 of the machine that you're using. It doesn't matter you are using Amazon EC2, you are using Azure Cloud, Azure Compute, or Google Compute. Images are nothing but simple images which we can copy and install it anywhere. You can make your machine image from a local instance as well to make sure your all the configurations are up to date and all. And these are like converted into a single file which we can boot up into your machine, so that your configuration of your EC2 is like EC2 or a machine is configured to exact point that you want without doing much of a trouble. So let's talk about what we're talking about in this talk specially. So we'll be heavily, so at episode we are heavily using AWS. So we'll be talking about Amazon machine images. But this talk is not a cloud centric talk. This can be replicated for Amazon, Azure, Google, or even though your custom on-prem systems as well. And we'll be talking about Packer, which is the star of our show of talk. Uh, so just giving a point of building images in CI. So we all are fan of DevOps. We are all fan of what we call as building images into CI/CD, automating our tasks in CI/CD. But there are few tasks which are very complex while making it into CI/CD, which is image building. So just take an example. Uh, Okay, over here. So there are few points where you need to solve. One is notification. For example, your triggers are triggered, so you're in building in you're building machine images and with the help of Packer into your CI. So for it, let's suppose it's building. So what does a Packer do? So Packer is a simple tool and very easy and understanding tool. What it does is it's deploy an EC2 instance. It makes sure all the configuration file that are required to make your image properly into into that instance, and it runs that script over there. And with the help of that you can make a proper machine image. But there's a problem. So all this entire process of building an image is happening into your cloud or into your on-prem machine, and your CI has no control over it. So there's come a major problem of notification. How do we know that our machine is our image is baked properly, or it's not baked properly, or is there any error which we need to solve at runtime or do any other changes? That's the one problem that we need to face while building an image into CI server. Second is long running job. um, I'll give you an example of at episodes. The entire bootstrap script that is required to make a um, naive EC2 instance or Ubuntu image to a proper ready to run image, it takes around 20 minutes. So this is just the bootstrapping time that we need to make install all our dependencies. This is one time. Second time is from AWS end, which is how much time it takes to make that EMI ready for use. So this leads to our CI server a very long running job. And that's the best practice that we want to follow in CS, that all the tasks should be very lightweight, non-running, like lightweight, non-running for a continuous period of time in the simple GitHub action, like GitHub actions or any Travis jobs, but that's a long running job we need to make sure, because not all CI server gives us a feasibility to run for a 40 minutes or 50 minutes CI job, not for the free version, not for the free version, first of all. Uh, Second is fallback logic. What will happen if the EMI fee? We have to make sure all the applications that we are writing have a fallback logic to make sure if the image is failed, we have plenty of scope to uh, make sure our application run, because we have to maintain our SLAs, because we cannot be like the images fail, we are not running because there is no present image here, present image for available to run. We have to make sure that we have a fallback logic enabled in our application. Second is non-cloud images. So in terms of cloud, there are plenty of options that we have available, which is AMI for Amazon. Azure has its own imaging system. Same for Google. But for a non-cloud, like, I mean on-prem systems, there's a challenge comes. So we have to build a file. We have to build your file into a proper, make sure that file is built in a proper manner, stored in a proper manner. And while booting OpenShift or environment or any vagrant environment, you have to properly allocate those file to that environment to make sure all the infrastructure is spawned accordingly. Second point comes is observability and testing pipeline for the image building. So we all have seen there are plenty of options in terms of observability. There are plenty of tools that gives us observability in terms of Datadog, anything and everything. So, but we always have a testing pipeline enabled. So, what are the ways we can increase our observability and testing pipeline? Uh, First is Packer Validator. So, Packer by itself gives us a tool um, which helps us to validate what are uh, is the configuration file that we have passed as correct or not, or is there anything that we know that we need to add or remove, or is there a configuration error present in the packer file itself which will break our CI or break our builds. So that's the pre-built thing that packer gives. Second is build of interim images on GitHub event. So just let's take an example that I am raising a pull request from my feature branch to master branch, and how I'm sure that my updated configuration will work into the production. So because whatever testing that I have done is done on my local system or an instance, which is not exactly similar to the production, but may vary here and there in terms of testing. So what we can do is we can generate builds onto the GitHub event to make sure that all the events are uh, to make sure all the images are built properly and they are tested thoroughly. So what we can do is we can raise a PR from our feature branch to the master, and on that pull request event, what we can do is we can build an interim image and run all our integration test and all the parties, all the tools and everything onto the to make sure whatever image that we are going to make after that merge is like rock solid, to make sure all our SLAs, all our uptime, all our business requirement and everything is maintained at that point. Uh, Third is bots for real-time communication. So I'm a very big fan of the bots. So there are plenty of bots available in the market depending upon what your team is using for communication platform. So there are plenty of ways to we can make bots for Slacks, Discord, even for Google. I guess Microsoft Team, they are given us the API endpoints to send messages onto the specific channel. So we can build bots in terms of what are the when what to have a proper notification system for seeing the when an image is added, when the image is built, what are the configuration, when the integration testing is started on that image itself. So we can have this kind of notification services enabled. Fourth is third party tool integration for aggregation. So just as I mentioned that uh, image building with the help of Packer is not a continuous task. It's a kind of asynchronous task where your Packer creates another EC2 instance to your cloud provider. It installs this everything and anything and everything into that machine and make sure that the image is properly present for that images correct on that system, or the configuration related to that app is present in the system. But there can be the instances that how to view logs into your CI server, because not everyone gets the access of CI logs, or in terms of whenever you are working in a very close uh, security based company or a very uh, medical infrastructure or anything, Not every developer has a log, has an access to for seeing everything, every logs in terms of building CI, because there can be a crucial information that will be leaking into log, and for that not everyone has that access. So Packer gives us the ability to integrate third-party tools like Datadog, CloudWatch logs into it, so that all the logs related to the specific cloud building are exported to somewhere else, and we can have that access given to our developers or team to view logs and verify that image is being properly built or not. So this is just a simple example that we use in our company. So we have Slack enable. So whenever a master API gets merged into the master, so what we do is we mark our old AMI which was running as invalid, so that no future runs or no future instances can pick that up. Second is we tell that the AMI building is triggered for the master branch. This is the gives the overall objective of how the things will work. And we use Travis, so we have mentioned that please monitor the Travis log and all. And whenever the image is built successfully, so we give out that AMI ID for a specific Packer tool from the Packer, so that the specific AMI is built and the respective Terraform stack. So what happened is all the things are used, all the development, deployment, and infrastructure as code is maintained by Terraform at Epic source. And so the AMI is built, but we need to make sure that AMI is updated into the launch template or launch configuration in the stack. So we use Terraform to update those AMI into the stack respectively. And after that, we run an end-to-end integration test, so that to make sure that every image is built proper and it is thoroughly tested. So there are few pointers that I like to add, which is building of how we can make sure that our production environment and dev environment are very similar. So one is we can use Vagrant first of all to build our images locally and test it on a Vagrant environment, so that we can have an end-to-end understanding how the things are working, and make sure that the product testing environment is as close to as possible. Because for just to make sure that my app is running, that is the first basic requirement for any developer that we know, that we need to make sure that our app is running, whether it is giving a correct answer or not. So we can use Vagrant for making that environment ready, because Vagrant is a very small lightweight tool for building a small VM on or a very small machine as well. So we can use Vagrant to mimic our in production environment and test it thoroughly onto that. Then use GitHub events for making interim images, interim data processing pipelines. Slack and Discords are there for to make a third party to have a real time notification system enabled. Um, for like integration of third party tool is always the best. So Packer gives us a plenty of community tools which we can use and integrate. So like, is there any question and answer that anyone wants to ask?
Hey Davis, thank you. So it was such a nice presentation. So yeah, I have been using this for quite a long time, and I know how powerful it is. So everyone can think of this is a simple tool than any other tools by HashiCorp itself, if you compare in-house. But this is a pretty powerful tool if you use in the right way. So
Yeah, there's the one point that uh, we talked about a lot in like many cloud native formation, that we can use Kubernetes, we can use Docker Swarm. There are plenty of Dockerized environment, but we are forgetting the point that all our core companies, all our old companies, old not old as in, but there are plenty of companies which are running on non-Dockerized environment, because their environment cannot be Dockerized. Just to give a perspective of, let's suppose you have a heavy NL, natural language processing machine learning model that uses around 13 to 14 models at any point of time. So the total image that is going to be result out if you, after you Dockerize that environment, will be 13 to 14 GB. So that's not a good practice to use that Dockerized image. So many of the companies use these approaches like non-Dockerized. So what they do is they install it on runtime. But what they are missing is they can build an AMI which serves the same purpose, and it reduces the SLAs to make sure everything is working smoothly. So this is one thing that we talked about Dockerized environment, but we can use this for our old, like all our legacy applications and move them ahead to a very CI/CD manner.
Cool.
Yeah,
Yep.
exactly.
Hey team, anyone has any questions for Devesh? So we have got 1 more minute. Okay, I'll take that as a no. And if you guys have any questions, please do post them in the chat and also in any community forums. And Devesh and the team is happy to help you all as well. Hey, once again, thanks, Devesh, and have a great day.
Yeah.
Okay, now we've got our next presenter, Anirudh, and there'll be a short presentations for us, and we have talked more about technology and like core technical skills. Now, will there always lead to success? In my opinion, it's a no. So we have to have a great leader who can actually grow the team along with him. That is the only way to have success. And now, so when you talk about startups, they always struggle with two things. One, the money, and the second thing is always about time. I would say maybe the right time of a right guy. So that's what they actually fail in. So now Anirudh is going to talk about how you can actually do much more of this very effectively for a great success. Now, with that, I welcome Anirudh to start your presentation.